So I'm going to email everybody again. People who are not here, they should know what we are trying to do. So let's go over to the homework problem. So this is, I believe, some of the homework problems. Okay, 2.6. Let's do this. So I want to share with you the maybe chapter one. Yeah, chapter two. Let's start from here. Chapter two, problem six. This is our homework problem. For the system shown in the figure, derive the relationship between the velocities VA and VB. So let's solve this together. So I will start from this like a datum line. If you see, this is my datum line, and then usually we do the length of each chord and this make our own axis like S sub A, showing this is the datum line and this is the S sub B. So now if you take a look, there is another pulley here. So I have to assume this is S sub C. I will say S sub C or C point C. So this way, now if you take a look, there are two ropes, correct? One is rope one, the other is rope two. So length two. So can you do the length of the rope one looking at this diagram? So I will say if this is my point here, so I can write down here L1 equals to S sub B plus S sub B minus S sub C times I should delete this one a little bit to bring it on the right hand side here. Let me rewrite here again. It should be two times, because if you take a look, this is the same length as that of the other. Oh, 1 second. So I want to write down SB, sorry, I was doing correctly, SB minus SC. Do you agree with your professor? Because I want to measure this length, which is SB, this length, minus SC, the length of this middle pulley. Let me know if you have some comments about it. So this is the length of the rope one. Let's find out the length of the rope two or the cable two. So how would be the, so if you take a look, this is S sub A. Let's start from this piece and then we go over to this piece. This is two times. So can I write down like plus two times S sub C? Now, if you take consider these two equations, now we have to go from position to speed. How would you go from position to the speed? You have to take the time derivative, So let's take the time derivative here. So time derivative here for each a equations 0 equals to 2 v sub b You have to do this operation on the other equation as well. Left hand side is 0 because the time derivative of constant length is equal to 0, and v sub a plus 2 v sub c. So now these are two equations. Now we can eliminate, these are two linear equations. You can easily eliminate these two, v sub c, because we want to find out the relationship. So can I write down the math here? So you can write down the this equation in rearrange, just rearranging to, if I multiply this 4 v sub b minus 2 v sub c, so I can cancel this out. So you're left with va plus 4 vb equals to 0. So what is the relationship between vb equals to, I'm sorry, this is 4, this is, let me rewrite here. This is vb equals to, now, if you take a look here, this is actually VB. Hmm. So the thing is, in our case, let me explain to you. If I this when this moves downward, when this moves downward, then according to, okay, this moves downward, this moves upward. So that's why negative sign. Negative sign means that the 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 axis for VB, it is positive when it is going from away from downward from the datum line, but negative means it is going upward. So that's what, so this is the relationship, this is your answer. Do you have any question, guys? Have you understood this one? So let's do one more problem. Oh, this is not, so the other app. So let us solve this problem together. The block in the figure 2.14, this is our homework problem. So you came little late, we have decided to give the quiz for this Saturday, which will cover only these problems. There will be two problems from this chapter, and I will open the quiz from, should I open it from 6 a.m.? Some people they want early, or 7 a.m. to 1 p.m. It doesn't matter. Okay. So now if you take a look, the block in figure, this is the block, okay, has a mass of 11 kilograms. So of course the weight x downward, and w sine theta cosine theta. I just resolve this weight into two axes, imagining this is my x-axis, this is my y-axis. Now let's do the let's read this. It is initially at rest. V initial is 0 on a smooth inclined plate. When you see smooth, it means the friction between the block and the surface. This is 0. Force of friction, I would say, let's write down F, F sub small f is 0. Smooth surface. and then with a spring stretched to zero point 0.5 meters. So now look, this force, let me rewrite, is if you take a look, this force will push this block further upward, okay, and the spring stretches, I will say S2. uh, Once it is on the smooth surface, 1 second, this is S1, initial stretch is zero point 0.5, and then a constant force is applied, this is 400 newtons, parallel to the plane, pushes the block up on the inclined plane. Compute the work done. So we have to find out the work done by all forces. So now you will see there are how many forces are there. You can see this is force 1, applied force due to the spring, force 2, and this force. So three forces are acting on the block, which we have to find out the work done. And you guys already know the work done is force times the net displacement or the net distance covered. Compute the work done by all forces acting on the block as the block is pushed 2 meters up the incline. So S2 equals to, I would say 2 plus zero point 0.5. Final position is 2.5. Initial position is zero point 0.5 meter. Final position of this block is 2.5. Imagine this is my what we call the initial datum line, maybe you can say. Now the spring force, it is equal to, sorry, the spring constant, it is equal to 44 newtons per meter. And work done by the spring force, I will say it is half k times the net displacement square. So initial, let me write down here, S2. So let me write down the numbers here. So k equals to 44, S2 is 2.5, S1 is zero point 0.5. So open your calculators and help your professor to tell me what is the answer for this spring force. One student say 132 Newton meter. Any other who verify? You verified? That's good. So this is a spring force. Let's find out the force, the work done by the force, applied force. This force is how much? 400. It is 400 newtons, and this block moves 2 meter up. So when the block moves up the plane, force is 400 times 2 meter is the distance it covers. So I would multiply this force, applied force, by 2 meters to get the total work done by the applied force, external applied force. Okay, now you will see the third force is this along the plane. Along the plane, that is important. You have to consider those forces which are along the plane rather than perpendicular. Perpendicular to the plane, they don't have any meaning because they are canceling the uh, work done in that case. So W, I was gravity, work done by gravity. I will say the work done by force. Gravity is equals to W sine theta times how much is W is 11 g, correct? 11 g. Let's write down the value of g, which is 9.8. Sine is 30 degree, correct? And times 2. Agreed. So let's do the math here. I can do it on my computer. 2 times sine 30 times 11 times. You can also verify. I got 107.8 Newton meters. You can verify at your end. Now we have found this. Now let's make the net work done. The net work done would be equal to, like, this is a block. So let me show you again. Let's draw this free body diagram. This is a block. And this applied force 1. Spring force will be opposite. I would say W, the work done. Let's write down the spring force, which is minus F sub K. And then gravity will also this way. So these are the three forces. So let's find out the net work done of these three forces. W sub F positive, negative W sub K, negative W sub G. So we already found the numbers 132. So let's see, W sub F equals to 800 minus 132, 10. What do you guys get if you find the net work done? 800 minus, I got about 1561, almost that much. So let's see, this is our net work done in moving the block up the inclined plane for 2 meters up. Do you understand this? This problem was a little bit easier. So let's go to the next problem. So let's start our next problem. Please draw the diagram. The question is a mass m1 moving with a velocity v1. So this is related with the angular momentum. So let me explain to you. But let me read the first of all, let's read the question. It strikes and becomes embedded in the pendulum. So this bullet or this mass becomes a part of the pendulum after it hits the pendulum, as shown in the figure. Assume the pendulum is a slender rod of mass m2. So this rod has a mass m2. So and determine the angular velocity of the pendulum. So of course, once the bullet hits the pendulum, it will start moving. Okay, now it is asking you when it has the angular displacement or find the angular velocity. So we have to find the angular velocity after the bullet, after the mass hits the pendulum. So before impact, what is the and after the you will consider these factors for angular momentum. It's up. Oh, now the angular momentum of our point is I omega. And you also know that angular momentum can be written like mv r. So when the bullet hits this pendulum, so what is the angular momentum of this bullet? And when it is just at the point when it starts its kind of motion. Okay, so mv initially r1 v1. So m1 is how much is the m1? It is 0.8. v1 is 10. r1 is the distance from the axis to this point where the bullet or the particle hits the pendulum is 0.5. So is it 4? Now let's do the other side. So the after it impacts, so I would say HO2 is I. I is a combination of three. I would say a parallel axis theorem you have to apply. So let's use this formula Ig plus I for mass m1 plus mass 2 times L square. You know the parallel axis theorem. So this is not kind of moving about its shape axis mass center, but it is moving about the axis away from this. So you have to consider this additional term other than this term. Yes, what is Ig for a pendulum which is having this shape? So I will say 112 ml square. The mass of pendulum is 4. The length of the pendulum is 1.33. Let's write down 1/3 kilogram meters. This is the mass moment of inertia about the symmetrical axis. Since it is not moving about the symmetrical axis, so we have to use the parallel axis theorem, which is having additional term of this m2l square. You guys already know about the parallel axis theorem. So what is m2? M2 is 4 kilograms. So let's write down m2l square, 4 kilogram times the length So now the mass moment of inertia due to the particle which has become embedded into the pendulum. What is that? So if you take a look here, this is again m l square. So no, I'm sorry, this should be zero point 0.5, not the complete L, but it should be zero point 0.5 here. You do the math. What do you guys get for this one? 0.8, 0.8 times 0.5, 0.2, correct? So let's do this is zero point 0.2. So zero point 0.2 plus 1/3 plus 4, 4.5. This is a total mass moment of inertia. You have to multiply by omega. This is kilogram meter square, and H HO sub 2 you will multiply by I equivalent I times omega. So I equals to 4.53 omega. That is equal to HO1. That is before the moment, which is 4. So I can write down 4. So let's do the math here. 4 over 4 point, I got 0.882. Do you get the same uh, angular velocity? Yes. So this way you have understood. I walked over to this angular momentum last time. If you take a look, angular momentum, this is the parallel axis theorem which we learned last time, and we went over the I omega. You see, we talked about the angular momentum, which is mvr equals to I omega. We went over it in the last lecture. The linear momentum is represented by letter G, and mass times velocity is the linear momentum, but angular momentum is linear momentum times the perpendicular distance of the axis of rotation to the body. So let's go to the next question in our homework problem. I want to copy and paste the problem here. The question is for the gear system shown in the figure. So assume that the shaft inertias and the gear inertias are I1, I2, I3 are negligible. So these are the inertia I1, I2, I3. They are very, very tiny. Like if the mass is so small, we can ignore their mass moment of inertia, very small. But the shaft has the mass moment of this shaft I4 has a mass moment of inertia. So let's write down I4 is equal to 0.02 kilogram meter square, and I5 equals to zero point 0.1. So which one is a bigger shaft? I5 is heavier. That will explain to you. Looking at the value, the numbers, it will tell you this is a bigger shaft. And now the ratio is given, speed ratio from this angular speed w omega 1. This is omega 1, this is omega 3. This is omega 3, and the relationship is given. Let me write down omega 1 over omega 2 equals to omega 2 over omega 3 equals to 1. This is the ratio between the gears and the shafts. So now we can say that I inertia of gear 1 equals to inertia of gear 2 equals to inertia of gear 3. They are all equal to negligible, means zero. Very, very small gears. Okay, we can ignore their inertias. So derive the system model in terms of omega 3. So you have to derive in terms of, I will say, this is torque, okay? External torque, this I equivalent. So let's do the derivation. But before I do that, you know that that Newton's second law states that all the forces they are equal to mass times acceleration. In the translation case, when the body is having a translation motion, but in this case, this is not translation. This is the angular motion. So the same Newton's law becomes all the moments they are equal to mass is replaced by mass moment of inertia, and x double dot is replaced by omega dot, which is also some books they write down theta double dot or alpha. Sometimes they are angular acceleration. They are the same things. Okay, the same thing. So all the torques. In this case, we just have one torque here. Applied torque equals to I equivalent. I would say I equivalent times omega 3 dot. So let's find out what is our omega 3. This is the final. What is I equivalent in our case? So let me show you that if you apply the kinetic energy formula. So let me grab this picture again. When the shaft is rotating, this shaft is rotating, uh, this one. So with this angular motion, so kinetic energy, I would say total for shaft one, kinetic energy for shaft one. Is it shaft? Let's say it is kinetic energy is for shaft one. Let's say sub 4. Kinetic energy is sub 5. Now, what is kinetic energy of shaft one? Half I4 omega 1 square. Agreed? And kinetic energy for shaft, which is numbered as I sub 5. So half I5 times omega 3. Now, the question states you have to replace omega 1 in terms of omega 3. How would you, this is 3. How would you go from omega 1 to omega 3 using this gear ratio? Okay, let's go from here to onward. I'm going to copy this again. Copy this. Omega 2 equals to 1.4 omega 3. So if I replace this omega 2 by this, so 1.4 squared omega 3. So this is the gear ratio from the first shaft to the final shaft. So the second shaft where we just have two shafts. Okay. So we have to use this relationship. So let's see what is this answer. Is it let me check. 1.4 squared 1.96. So this is the gear ratio from shaft 1 to shaft 3. Hmm. So now let's go to this equation. I want to grab this one. Okay, guys, I want to grab this one. I want to replace this omega 1 by omega 3. So can I do like this? Um, if I do this, because here this is omega 1 square, so can I take the square on both sides? And if you take the square, what is this? 1.96 square. I got 3.84, correct? So let's do this 3.84. Now I'm going to write down half. Let's plug in the numbers. I4 equals to 0.02. Agreed? I4 equals to 0.02. Correct? Let me make sure it is 0.02. And then omega 1 is omega 1 square equals to 3.84 omega 3 square. Is this step clear? What I did? Everybody is with me? Yes, I just doing some rearrangement and trying to plug in omega 1 using omega 3 relationship relations. So let's do the next part. So can I do the I half I5? What is I5? I 5.1. Agreed? So it is zero point 0.1 times omega 3. And this is square. Let me rewrite here. Make sure this is my omega square. Now let's let's take out some of the common terms. Half is common and omega 3 square is common. So whatever we're left with, can you tell your professor what is this multiplication? 3.84 plus zero point 0.1. This is all I equivalent. Okay, this is what we have to do. What do you guys, if you do the math, can you help your professor? In my notes, I this is equal. Let me check. This is zero point 0.1. Okay, in my notes, this is equal to 0.177. Do you agree with these answers? If you agree, then we can move to the next step. Yes, students agree with this one. So now let's go to the next step here. Let me take this uh, picture here again. So this torque is not directly applied to the second shaft. If you take a look, this torque is applied to the first shaft. How can we relate the same torque, effect of the same torque on this shaft? We have a solution for that. We know that uh, we know that power equals to torque times omega. Agreed? This is power. And torque of shaft, let's see, it is shaft 1, which is represented by, let's do this omega 1, omega torque omega 1 equals to torque to omega 3. So what is torque 2? That's what we need. Agreed? That's what we need to apply on the second shaft. So what is omega 1 over omega 3? This is equal to this relationship. Omega 1 over omega 3 equals to 1.96. Agreed? So this is what we need. So I can write down 1.96 times T1. This is what we need in our equation. This is our equation. I will say this is our equation T sub 2. And then let's write down omega point 177 omega 3 dot equals to 1.96 T1. So this is your final answer. Please note it down. So, any question, ladies and gentlemen? You guys are good? Can you solve such problems? These are the homework problems. Okay. I would highly recommend when you go home, do these problems again and watch the video lectures. Do you have access to MS Team videos? When you go home, you can also watch the. I will upload on the YouTube because this is an extra work, so I can try helping on the YouTube video. So let's do the next question here. Problem number this one. This is our homework problem. So obtain the equation of motion in terms of x. Neglect the mass of the pulley. So we know that if we if we use this block, then there are two forces. Acting downward is the gravity force, acting upward is the tension in the cable. But there is a easy way to remove the gravity force. When you write down equilibrium, then in equilibrium, what happens that when you leave this mass, the spring like mg equals to k times static deflection. So this equilibrium will help everybody, me and you, that will eliminate the need for considering the weight or the gravity force. We will just use the dynamic displacement, not the static displacement. You understand me? So that's how if you don't need to worry about this force in the free body diagram. That way you can explain to your professor that since this is equilibrium and the gravity force has been taken care of by the static deflection of the spring, now the spring stretches beyond the static deflection, that becomes the dynamic deflection. So now let's see the force, all the forces, mass times acceleration. Agreed? So this is my acceleration, the displacement, and the upward force. So if the mass moves downward, tension moves upward. So I would say negative T equals to mass times acceleration. Up until here, Have you understood? There is just one force, upward force. The mass moves downward, the tension will move upward. That's why we have a negative sign. Agreed? Now, how do you find the relationship? Now, let's do one more thing here. If you take a look, so the tension in this cable is downward, and upward is the force due to the spring. So if I do the force balance here, so F sub K, which is equal to K times Y. This stretch is the stretch in the mass, the spring, which is K times Y is the stretch. Center of the pulley is moving with the displacement Y. Let me tell you that the center of the pulley is one half the displacement of the circumferential motion. So if this end moves downward, this end also moves upward. So I would say that y is one half to the uh, displacement of the circumferential points. You agree with me? We did that proof last time. If you take a look here, we did that proof in our last lecture. I believe I did that one over here. Yes, x equals to 2 times y, where x is the point on the external arc. You agree with your professor? So this is the relationship which will help us to just plug in the numbers. And now we can find out the force of the spring is K times Y, and the tension in the cable is 2T. So T plus, so if the force balance, what's that force balance? Upward, downward force. So I would say upward force is F sub K, downward force is T plus T. This force as well as this force. So 2T. And since the question is stating you have to find out in terms of X, we don't need Y. So, but there is a relationship between the middle point of the pulley and the external perimeters point, correct? What is that relation? Y is replaced by X by 2. So K X by 2 equals to 2 times T. That means T equals to K X by 4. And now you can plug this over here. Find out the equation of motion. Can I write on minus K X by 4 equals to mx double dot? This is your equation of motion of this. This is not three dots. This is just my human error. Okay. This is double dot. If something is not clear, you can stop me to ask some questions here. Please note it down. Let's do one more problem. Derive the equation of motion for the system shown in the figure 2.31 for small motions. neglect the pulley mass. Okay, so this is the angular motion. Okay, in angular motion, we know that all the moments, they are equal to mass moment of inertia times the angular acceleration. That's what the equation of motion becomes when you have the angular vibration or angular motion. And let's see, if you take a look here, that this is R. So what is the moment of this? If this pulley, let me show you externals. So if this moves to the counterclockwise, and the spring will try to move it clockwise, so it would be negative k times x. Now, what is x? This is the net displacement in this stretch. So if this moves to the left, if this mass moves downward, this pulley moves counterclockwise, it will pull it to the left side, and spring will be stretched. So let's say this is the stretch. So this is angle theta. So what is x? R2 times theta. You agree with your professor? Take a closer look. The spring is hooked up to the larger pulley, and arc length is x equal to r times theta, r2 times theta. And for small angles, we can assume that arc length equals to straight line. We can assume that one. So now you have understood this part. So what is the moment? Because we are trying to, what is the moment of this uh, spring force? You know, moment equals to the force times moment arm. Do you know this relationship? What is the moment arm? This is R is very bad here. So let me write down here. So minus times moment arm. So moment, this is my force. Okay, this is my force. So moment of due to this spring equals to negative k times r2 theta. This is the force times the moment arm from the center of the pulley. Suppose this is, we are taking it from the center of the pulley. That is the moment arm r2. The radius of the larger pulley is the moment arm of the force, spring force. You agree with your professor? So this is the moment arm for that one. And that's the thing, we have to write down the equation of motion. So now so this is I. What is I for the smaller pulley, which has been rotated by smaller this mass? So can I write down I equals to m r1 square? And we know the equation of motion, like this is the equation of motion. Okay, so I would write down, like, let me write down like again here, equation of motion, mass moment of the moments squared theta equals to I times theta double dot, and I equals to m r1 square theta double dot, and that is equal to minus k r2 square theta. And now we already know the x equal to r theta or r2 theta. So do we have to find out this? Let's find out in terms of x. Let's find out in terms of x. So we know that x equals to r1 theta equals to r2 theta. So this our answer is almost complete. So I can rewrite just rearrange everything in terms of x dot x double dot. So what is my r2 theta? This one, r2 theta. Can I write down like this? Because r2 theta equals to x. Agreed? And then can I write down the other portion, this portion, like this, mr1 x double dot. Why is it x double dot? You know that x dot equals to r1 theta dot, and x double dot equals to r1 theta double dot. You just have to differentiate on both sides. Whatever you do on the left hand side, you have to do the same thing on the right hand side to keep the balance of the equation. So this is your answer. So I have shown you the equation of motion in both theta variable and in x variable. Have you understood this equation of motion? Okay. So let's do the last problem of our I've solved, but you will do it by yourself again. I have skipped two, three problems. I, but you will do it when you go home. You will do them again, and I'm gonna show you the last problem of the chapter of this homework problem is 2.34. You see the homework is almost finished in 1 hour. The question is, for the system shown in the figure, solid cylinder of inertia I and mass uh, m. So you see inertia I and mass m. What is the reason of telling the same roller two different variables? Because the roller rolling as well as moving downward, correct? So you have to consider the kinetic energy of both cases. So how would you find it? So let me show you without slipping. So neglectably obtain the equation of motion. So let's use the energy method. Do you know what is energy method? That sum of the energy method is easier in this case. Energy method to find differential equation of motion. So let me show you what is the energy. Kinetic energy plus the potential energy equals to constant. And then you have to take the differential of that one. That gives us the differentiation of this equation. I will say equation 1. That gives you the um, equation of motion. So let's do the math here. What is the kinetic energy? Kinetic energy is due to the motion of this roller. This is a rolling drum as well as it's a mass which displaces. So consider this as kinetic energy due to the rolling and kinetic energy due to the translating. So rolling, it is equal to half I omega square. Kinetic energy due to the translation, it is equal to half m v square, or let's write down in terms of x variable. Okay, agreed. Now what is the potential energy? Potential energy is stored inside the spring. Springs, they don't have kinetic energies. They just have the potential energies. I think the connection is lost. Are you guys able to hear me? Can you see the screen?
Yes.
Uh, okay, thank you. So now I was talking about the potential energy is stored inside the springs. So now the spring potential, I would say potential energy to the spring, it equals half times k times the net displacement square. Now you have to see there are, how would you find out the net displacement here? So look, this is the external surface, external point here, correct? So and plus this also moves here with theta. I would say delta S will be equal to 3 times the stretch. Why is it 3 times? Because if the wheel moves down a distance x, the spring stretches 2 times the x. Agreed? So if you consider this wheel, okay, this wheel moves down. Agreed? So this the end will be experiencing 2 times. I would say let's split it up. X equal 2 times x plus x. This x is also the rolling x, the arc length. You see my point? So the total displacement, total stretch in the spring would be the rolling stretch plus the translating stretch. You see my point? So this is the net displacement. So can I write down like this? So half potential energy in the spring equals to half times k times 3 times x square. So let's plug it in over here. So the total energy in equation 1, kinetic energy is half I omega square. Now omega can be further simplified in terms of x. So let me rewrite here the x, since we know that v equals to r omega. Do you know that formula? So tangential velocity. So x dot equals to r omega, and I can write down omega equals to x dot over r. So let's write down here. So over here, equation one. Equation one is total kinetic energy, which is equal to half I omega square x dot over r plus half m x dot square translation portion plus the spring potential energy equals to constant. Agreed? Now let's open this parenthesis here and see the answer. I'm sorry, this cancel. So let me write down here. So if we are almost done here. If you do the math, half is cancelled, and so if you consider this one m, now we are differentiating. After we differentiate this term, so let me rewrite here. I skipped one step. So once you differentiate it with respect to time. So what is the differential of this term? So you will see I over r square is outside. 2 times x dot times x double dot, because you have to apply the chain rule. This is for this term. So let's for the other term, like m is outside, 2 times x dot times x double dot. And then for the last one, k, 3k, oh sorry, it's 9k. It's not 3k, but it's 9k, 2 times x dot. Am I, do you understand what's going on here? Correct? Equals to 0. Now you see one term cancels. This one is coming in each, we can cancel it out. 2 is also cancelled. Let's combine m with I over. I can rearrange. This is just rearrangement, okay? This is in terms of x double dot. That's what I wanted from this term. And the other term is left 9kx equals to 0. This is my equation of motion for this system. Now, if you take a look, the standard equation of motion is for mass spring system is this equation. Now, can you find the resonance? Yes, you can. Look, you have to just normalize that acceleration term. So x double dot plus 9k, whatever this is, you will write down in the denominator and equals to x. This is now standard form. Whatever it is omega n square. You see, resonance can be found when you compare the standard equation with the actual equation. So omega n square equals to 9k over m plus I over r square, or take the square root on both sides to find out the natural frequency of the of this angular vibration with the drum. With that, you have finished most of the problems. Any, let me stop the recording, and we will just end the lecture. So guys, I'm